The Lockheed SR-71 Blackbird was confidently flying at speeds of over 2,200 miles per hour back in the 1970s, and the North American X-15 could reach the edge of space a decade before it. In those years, it seemed that the bright future of supersonic aviation had already arrived. However, after a bright but short flash of records, the world plunged into laboratory stands for decades, seasoned with pompous slides with unrealistic promises. Today, the role of the legendary Blackbird has been taken over by a completely new hero, the unmanned prototype Quarterhorse from the tech startup Hermeus. But the mission of this aircraft is not setting records, but instead turning hypersonic travel into everyday reality. After the wild experiments of the 20th century, it seemed that hypersonics would be with us for a long time. But each subsequent step in this industry was too expensive and unjustifiably risky, especially for the government. The same rockets, for example, could only withstand a couple of minutes of operation in extreme modes, and reusable manned vehicles simply ran into materials that melted right before our eyes. No, of course, even after hypersonics went into hiatus, engineers and scientists continued to study heat flows, shock waves, and develop innovative materials. But all of this moved from the skies to the desktop, not the other way around as it had been before. And in general, the military's priority has shifted towards drones and high-precision weapons. However, decades later, interest in hypersonics has returned with renewed vigor. Modern control systems and a rapid pace of iteration have opened the way for many talented teams, giving them the chance to turn hypersonics into a working tool for aviation. One of these teams was Hermeus, which began its journey in 2018 and has now become the locomotive of the future of hypersonic transportation. Moreover, both passenger and military. But first things first. Quarterhorse is an unmanned, high-speed technology demonstrator from Hermeus, whose primary goal is to break the 50-year-old Blackbird speed record and demonstrate the full capabilities of another of its proprietary combined cycle engines, the Chimera. When we talk about airliner engines, whether it's the Boeing 777 or the Airbus A350, we're talking about classic turbofan engines. The principle of their operation is as follows. The compressor sucks in and compresses air, after which fuel is injected into the compressed flow, which burns, turning the mixture into a hot gas under high pressure. This, in turn, spins the turbine, which simultaneously feeds the compressor and throws out the residual energy as jet thrust. This whole process is designed for optimal modes and speed ranges from takeoff to cruising speed of 0.8 to 0.9 Machs, or about 560 to 600 miles per hour. And their main advantages are efficiency, silence, and fuel economy. The Chimera is a completely different beast, a turbine-based combined cycle engine. Like its ancient Greek namesake, it's a hybrid and has learned to effectively handle its tasks in two modes. Up to Mach 3, it operates like a conventional turbojet engine, where it's pulled by a classic gas turbine circuit. When the inlet air becomes too hot and fast and the turbine can no longer hold out, the Chimera switches to a ramjet mode. To do this as painlessly as possible, it's helped by a pre-cooler developed by Hermeus, which increases the maximum speed of the gas turbine engine by reducing the temperature of the inlet air. In ramjet mode, the air is compressed by shock waves in the air intake, fuel is injected directly into the flow, and all this burns without a turbine, allowing the device to accelerate up to Mach 5 and even a little higher. Simply put, the Chimera is not designed for economical cruising at 30 to 40,000 feet, but for sustained operation in conditions where a standard airliner engine would simply fall apart. It can be compared to a reliable diesel engine for a bus and a hybrid sports car with a jet rocket where the gear can switch to a completely different class of movement. But the Chimera is just the first version of the engine that powers the Quarterhorse Mk0, Mk1, and Mk2. It was built around the GE J85, a compact turbofan that's ideal for demonstration purposes. It took the team just 21 months and $18 million to build, which would be an insane amount if the Chimera were a government program. In December of 2022, Hermeus announced that for the Chimera 2, they'd chosen a completely different engine as its basis, the Pratt & Whitney F100, a proven turbofan that's flown tens, if not hundreds of thousands of hours in the McDonnell Douglas F-15 Eagle and General Dynamics F-16 Fighting Falcon. So in Mk3, can we expect an even more advanced version of the Chimera 2 engine? This, albeit radical, re-equipment of an already existing engine base allowed the startup to save a lot of time, focusing on bringing the pre-cooler and other components of the Chimera 2 to near perfection with a goal of reaching speeds of 3.3 Machs and more, breaking the SR-71 record as early as 2026. In the meantime, in 2025, the company plans to roll out the Quarterhorse Mk2, the size of an F-16 fighter, which, despite still using the first version of the Chimera, will demonstrate new defense capabilities in supersonic mode up to 2.5 Machs. Construction of the prototype began in December of 2024, and its testing will be conducted by the end of the year. When you're dealing with 4 versions of a single machine, as is the case with the Quarterhorse, it's hard to do without additive manufacturing technology to quickly produce complex metal parts. The same Chimera is 15% 3D printed. This allowed the team to standardize parts, abandoning some of the traditional processes of casting, forging, machining, soldering, and welding. Although no matter how you look at it, a freshly printed part still requires heat treatment and surface finishing. To produce them, Hermeus used Velo 3D Sapphire and Sapphire XC printers calibrated to print parts from Inconel 718 alloy. The former has a working area of 315 by 400 millimeters, while the latter is capable of printing parts 600 millimeters wide and 550 millimeters high. Inconel 718 was not chosen by chance. According to Glenn Case, Chief Technology Officer at Hermeus, this corrosion-resistant nickel-chromium material is simply ideal for hypersonic aircraft due to its high strength and amazing resistance to oxidation, even at temperatures close to the melting point. When your airplane is hurtling along at Mach 5 or more, the stagnation temperature can easily break 1900 degrees Fahrenheit, 800 Celsius. But if you look at the equilibrium radiant temperature along the surface of the craft, especially on the leeward side, you can see that it's not only giving off a lot of heat into the body, it's also dissipating it efficiently through radiation. But if you look at the radiative equilibrium temperature along the surface of the vehicle, especially the leeward sides of the aircraft, you're dumping a lot of heat in the airframe, but you're also rejecting a lot of that through radiation. Under such conditions, titanium alloys or titanium itself are also ideal. This is why Hermeus made extensive use of this lightweight metal for much of the Quarterhorse airframe. But the Quarterhorse is only the first brick in the pyramid that Hermeus is building. The next big step is Dark Horse, a larger Chimera 2-powered hypersonic military UAV designed for reusable defense and reconnaissance missions with a beefed-up engine profile and more stringent endurance requirements, which was expected given the repeated investments by American agencies into the promising startup. For example, in 2021, when they signed a major agreement with the U.S. Air Force worth $60 million, or in July 2022, when Hermeus was included in the U.S. Air Force contract with a funding ceiling of $950 million. Although investors, like the one we know better as the head of OpenAI, Sam Altman, were probably not so much interested in the military Dark Horse, but rather in the team's magnum opus, Halcyon, a stylish hypersonic business-class passenger jet designed to carry up to 20 passengers in the footsteps and routes of the once legendary Concorde. After all, you must admit it's cool to get from New York to London in 1.5 hours instead of the current 7 to 8 hour flight, especially if you're the CEO of companies like OpenAI, where every minute counts. But until work on Quarterhorse is completed, it's difficult to guess specific dates for production, much less commissioning of Halcyon, though Hermeus representatives previously mentioned to the media that they intend to begin the first tests of Halcyon by 2028. And when you consider that these same guys designed and built the recently successful tested Quarterhorse Mk1 in just 204 days, and then carried out a comprehensive ground campaign at Edwards in just 21 days, we have no reason to doubt their competence. At the same time, the industry standard for the creation and testing of a full-size aircraft is considered to be about 1,400 days or 3.8 years. This means that the speed of creation by Hermeus engineers is about 1 year versus 7 years for long-standing industry players, which can be called, without false modesty, a breakthrough in aircraft development. It's also important to remember the estimated cost of these innovative aircraft. In 2023, in an interview with Forbes, Hermeus CEO A.J. Piplikas said the first 3 versions of the Quarterhorse would cost less than $100 million. As for the vision for passenger aircraft, the team intends to deliver 500 Halcyon hypersonic aircraft to the market by 2035, with a price tag of over $200 to $250 million per unit. However, the true value of the Quarterhorse is not in the individual Mach speed levels or the achievement of new records set, but in the fact that it returns to us a once-lost discipline: build, fly, fix, and fly again. Thanks to devices with this approach, hypersonic flights will finally stop being built around a single wow shot and will move to a more practical plane, which is quite a breath of fresh air for us as aviation fans. What do you think? Will Hermeus be able to give us what we want with a hypersonic passenger aircraft before the mid-2030s? Or will it happen even earlier? Share your thoughts in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.